The speed of the water current started at 1 meter per second and gave rise to a deposit of microstrata or laminae prograding downstream. The flow of the current was then reduced to 0.5 meter per second. This provoked the deposit of large particles of sediment. Then, as the deposit thickened, the speed of current was increased back to 1 meter per second, and laminae deposited on the large particles. So the deposit was composed from top to bottom of beds or strata of small particles, large particles, and small particles. The three superposed beds prograded together from upstream to downstream. This demonstrated that the beds or strata did not form one at a time as required by the principle of superposition. They formed simultaneously. Nor did any one bed have the same age at any point as required by the principle of continuity, because they formed together and sideways. Each lateral part of a single bed or strata therefore had a different age. But something else was happening. When the velocity of flow was reduced, a second deposit started forming on top of the first, whilst the first was continuing. The two superposed deposits prograded simultaneously from upstream to downstream. When the velocity of flow was increased, a third deposit started forming on top of the other two, and all three prograded together downstream. Here we have a phenomenon of multiple beds of sediment forming on top of each other, vertically and sideways at the same time, the triggering mechanism having been simple changes of current. The laboratory experiments showed that where there is a water current, one layer does not deposit upon the other, with each layer being older than the one which covers it. This would therefore appear to be a major exception to the principle of superposition. Many parameters were tested, from very slow to very fast currents. None of them, however, provided an example of the principle in operation. The experimental results, therefore, did confirm the definition that the principle of superposition is a general or inclusive law, exemplified in numerous cases. Could it be that the authors of the principle of superposition had not taken hydraulic conditions into account? This possibility would seem to be confirmed by other experiments which showed that the principle of superposition only applied to very fine sediments depositing in water where there is little or no current. The principle applying in such limited conditions can hardly be considered to be a general or inclusive law applying in numerous cases. The fact that stratification formed parallel to the slope, exceeding an angle of 30 degrees, highlights the inaccuracy of the principle of original horizontality, which states that layers or strata form horizontally. It must be remembered that this principle is used by geologists to interpret past conditions producing the sedimentary rock we see today. Sloping strata suggested to them that movement had taken place, causing originally deposited horizontal strata to be tilted at an angle. The experiments show that sloping strata could simply be the result of sediments depositing on an inclined bed. It was shown in the laboratory that the principle of continuity did not apply to strata forming in a current. The strata formed laterally from upstream to downstream in the direction of the current. They did not superpose successively. Consequently, the stratum created in the laboratory did not have the same age at any point as asserted by the principles of stratigraphy. The stratigraphic principles had been used to obtain age correlations between geological formations separated by distances. This fact indicates that no account had been taken of the effect of local currents in the oceans or seas in which the sediments in these geological formations had been deposited. Strata forming in different parts of the same ocean or in different oceans would be subject to differing hydraulic conditions and could not be considered as continuous. The geological column was conceived on the assumption that the principles of stratigraphy applied as a general law with numerous examples. The laboratory demonstration that the principles of stratification do not apply where there is a current challenges the basis upon which the geological column was formed. As with particles of sediment, organisms get swept along laterally by strong currents and deposited successively in sediments in which they become fossils. When the sediments hardened into rock, the position of the fossils provided no indication of age. Fossil 1, in the upper strata, for instance, was deposited before fossil 2 in the lower strata. Fossil 1 could, therefore, be older than fossil 2 in the lower strata. The second major question was to what extent, if any, could these laboratory results explain geological formations around the world. The link between the two was provided by a reference in a 1994 publication entitled Grand Canyon. It contained an item contributed by PhD geologist Stephen Austin, which referred to two papers, one by sedimentologist D.M. Rubin, published by Sedimentary Geology, on the relation between hydraulic conditions and stratified structures in the Bay of San Francisco, and the other by J. Southard in Sedimentary Petrology, which summarized 39 series of flume experiments on the same relations. Rubin summarized these relations diagrammatically, showing the speed of current, depth of water, and size of sedimentary particles necessary to produce the different structures found in sedimentary deposits. Having recognized the same structures in sedimentary rocks as those in Rubin's diagram, Austin applied the relationships shown in the diagram to the Tonto group in the Grand Canyon. This geological formation extends for 800 kilometers from east to west and corresponds to a transgressive sequence of three facies superposed and juxtaposed. The upper facies is limestone, the middle facies clay, and the lower one sandstone. As predicted by Walter's law, the same sequence of facies is found side by side. By means of Rubin's diagram, Austin determined the hydraulic conditions that would have existed when the sediments giving rise to the rock facies of the Tonto group were deposited.